Good morning, everyone. Welcome. My name is Libby Spencer, and I am the sales manager at Enartis USA. Enartis is an enological product company. We sell a full range of premium winemaking products like yeast and enzymes. We're headquartered in Italy and have a presence in all major wine producing countries. If you are a winemaker, you're probably familiar with us. But if you are a grower, this may be your first experience with our company. So welcome, and thank you for joining us. A few years ago, we added a vineyard product to our portfolio. That product is called BluVite, and it is the focus of our webinar today. My hope is that you find the data presented compelling enough that you consider trying BluVite in your vineyard this growing season. I'd like to thank Cheryl Quist, the Executive Director of the Petaluma Gap Wine Growers Alliance. Thank you, Cheryl, for connecting us with your members. I hope this presentation is informative and adds value to your membership. Thank you for partnering with us. We have two presenters today. The first is Scott Welch, who is a vineyard manager for Jackson Family Wines. Scott is a second-generation grape grower. He grew up in the Ukiah Valley and studied viticulture and ag business at Cal Poly San Luis Obispo. Since graduating, he's been a vineyard manager throughout the North Coast for both his family and his current employer, Jackson Family Wines. He just completed his fourth growing season in the Petaluma Gap and is an ardent believer in the region's quality and promise. Scott has served on the Petaluma Gap Wine Growers Alliance board for the last 2 years and chairs the Growers Committee. Today's presentation will focus on a trial conducted during the 2020 growing season at the Bloomfield Vineyard site. Scott will tell you about that location as well as some of the unique challenges he faces farming that location. After that, my colleague JT Jaeger will share trial data collected from that Bloomfield site. JT is our Sustainable Vineyard Specialist and manages the BluVite project for Enartis USA. JT began his career in agriculture shortly after receiving his bachelor's degree in genetics at UC Davis. He started his career as a soil microbiologist working in the UC Davis Research Lab, and that led him to pursue his master's degree in soil and sustainability at the University of Edinburgh, emphasizing the importance of sustainable farming practices. Prior to joining Enartis USA, JT worked for a viticulture consulting firm where he specialized in soil evaluation, irrigation management, and nutrient management. After JT presents the trial data, you will have an opportunity to ask questions. You're welcome to ask your questions in the chat box on your screen during the presentation, but note that the presenters won't see your questions until the end. And if you find that chat box distracting, you are able to disable it. So with that, I will turn this over to Scott. Scott, tell us about Bloomfield and about your trial.
Absolutely. Thanks, Libby. Good morning, everyone. As you can see in the photo in front of you, that's a picture of our Bloomfield Vineyard. The Bloomfield Vineyard is located just north of the town of Bloomfield, or the small hamlet of Bloomfield. And if you're not familiar with Bloomfield, it's located on the Bodega Highway. A larger marker would be Sebastopol. The ranch is located about 10 minutes southwest of Sebastopol, still within the Russian River AVA, but definitely right on the border where it meets the Petaluma Gap. And it's a very cold site. And as you can see in the photo, the terrain is rather hilly, lots of slopes, and it kind of rests inside its own little valley. So it's a very unique part of Sonoma County. When I arrived at Bloomfield Ranch 4 years ago, one thing I noticed that we were doing a lot of cultivating at the ranch, disking every other row. Not heavily, but there was still cultivating being done. And so one challenge I set out to do was to try to convert some of the vineyard to no-till and see what we could do with permanent cover crops, get a mix of different plant species, hopefully nitrogen fixing plants and seeds, and try to establish something a little more permanent. And at that time, it was based solely on the topography of the ranch, and that the soils there have a lot of sand, sandy loam, and they can easily erode. So to start, when I first got there, that was the reason, was just, if I can do more cover crops and less tillage, I was hopefully going to save some of that topsoil. Lo and behold, as the years have progressed, I've learned more and more about that effort, and my company, Jackson Family Wines, is focusing more and more in that realm as well. And what I mean is, not only by this no-till system am I, hopefully improving my soil structure and retaining more topsoil in its place, but hopefully over time, I'm also going to be increasing the soil organic matter. And that's important because more soil organic matter is going to help for more biodiversity in the soil, more microbe activity, and also hopefully improve our water holding capacity within those soils. The entire ranch is irrigated strictly by rain runoff. So to irrigate during the season, we are reliant upon winter rain. So the other idea was, if we can increase our soil organic matter, hopefully that means less irrigation. So in these drought years, we'll require less water to make it through the season. And finally, last year, our company began an initiative as our entire vineyard organization to start trying ways to sequester more carbon, to start doing good for the climate and for the environment. And so my idea of no-till works in well, because less cultivation means, you're releasing less carbon into the atmosphere. And by using these cover crops and composting, we're going to start finding ways at Bloomfield to sequester more carbon. So on this next slide, I'll jump straight to our vineyard data. As you can see, overall, it's a fairly common look if you read through each bullet point. I mean, this is a very common look for vineyards in Sonoma County. Everyone knows Pinot Noir. It's one of our most popular varieties. Clone 667, another common one. Spacing, everything looks pretty similar. So all my peers and fellow growers on this call who, are growing Pinot Noir in the Petaluma Gap, Sonoma Coast, West Sonoma County, this is probably something that rings true to them. And another thing is the climate. So moving on to the climate, we will typically see a foggy morning in Sonoma County due to our proximity to the ocean. And then you get, 3 to 6 hours of nice weather, followed up by a windy afternoon when that fog begins to roll out or move back in. What makes Bloomfield so different is that sunny window in between the foggy weather and the windy weather is incredibly small. And so we're looking at a very short daily window where the vines are either going through photosynthesis, and then later on in the season, less time for our fruit to ripen. So that's the one thing that separates this ranch and makes it a little bit more extreme than the bulk of vineyard acreage in Sonoma County, is I feel this is a true cold climate growing site. And that's what led me to look into additional products like BluVite and other alternatives to, the common synthetic fertilizers that we still use. But just due to the difficulty of this site and the uniqueness of this site, I'm still trying to find new items that can help us maximize growth and maturity with this, small window that I'm referring to. So finally, looking at challenges ahead for this site, it's a large vineyard. It's over 200 acres. And as we move towards more regenerative and organic practices, we have to, take that into consideration, that it's going to be expensive, and there are going to be certain things we can and we can't do, especially with the terrain. Like I said, this isn't a 200-acre valley floor vineyard where it might be easy to run certain equipment more effectively. So we're looking at, slightly higher costs, and also on the site, we have historic lower yields. So high costs, low yields makes it very difficult. Our cluster weights are typically incredibly low, and also our cluster counts. So that required us a few years ago to begin leaving more canes. So we typically leave 1 to 3 canes per vine just to get our shoot count up and hopefully our cluster count up. So this might sound somewhat counterintuitive because we're talking about a very small ripening window, yet we're leaving more buds, more shoots, more clusters. But in effort to get to a viable yield, it's something we have to do. And so I see BluVite helping out in our trial site as I look for a product that can be applied to the soil where we weed spray, because we're still weed spraying the berm. But if we're going to have our permanent cover crop and then this small area without cover crop, my goal is to revitalize that small area of soil so that hopefully between our cover crop, our compost, and the BluVite treated area, that soil is doing all it can for our roots. And so then the goal would be with our, with all the shoots that we're leaving, we see less short shoots, better growth, because we're going to need every single one of those healthy basal leaves to produce sugars for us during that small window from, say 11 a.m. till 2 p.m. So everything just has to work. And so if we do that and if we see better growth, then that means we can be pickier with removing fruit. So we might leave more fruit than we need at first, but then that allows us to come back through and do the proper suckering and then fruit removal so that by the end of the season, we're left with, uniform growth, hopefully uniform ripeness, and we're able to pick a nice crop at around 2 tons per acre if we're lucky. So that's the idea, and I feel that by trialing BluVite in this section of our vineyard, we're going to see if we can achieve that, if we can achieve more uniformity, better growth, and at the end of the year, hopefully a better wine as well. So that's why we chose to trial this product at Bloomfield.
Fantastic. Thank you, Scott. That's a great overview. So then with that, JT, if you're ready, you can talk to us about what data you collected and what you found.
Yep, of course. Thank you, Libby. Thanks, Scott, for kind of setting the background to all this. I'm just going to, before we kind of jump into it, if you ever attended one of our other presentations, you already may be familiar with this, but these are the companies that sort of work together to make the BluVite technology work in the United States and also abroad. BluAgri, which is based in Italy, is our sister company, and they actually create the Vineyard product line. Libby has already set the background for this, but we work for Enartis USA, and we're actually sole distributors of the product in North America. And then finally, SOP is the company that creates the technology that goes inside the BluVite product line that allows the product to work. And this company's been around for the last 20 years, and they have many other products in staple crops like corn and soy, but also other perennial crops like almonds and olives as well. The venture into vineyards actually occurred about 6 or 7 years ago in Italy, and that's why we're here today. They've also got peer-reviewed publications in livestock from UC Davis, Cornell, and the University of Milan, and actually more recently had a publication released in corn production, maize production. So more to come on that as well. Moving on, there is a global presence for commercial application of the product. I'm based in Sonoma County in Windsor, so we obviously have a presence in North America, United States, Mexico. The product was created in Italy, so obviously in Europe, France and Germany, but also South America and South Africa. I'm not going to spend a ton of time on this slide, but here's some of the commercially relevant varietals that we've had commercial trials on with clients of ours. All of the the varieties that are actually in bold are the ones that we've directly trialed with growers in the United States, California, Oregon, etc. But today we're talking about Pinot Noir. Again, I'm not going to spend a ton of time on this slide. When we send out the recording of the presentation, these links are live. These are the TDS, the technical data sheets. It has application method, volume, rates. There's 2 different ways of applying it. You can spray it on the soil surface or fertigate it. So yeah, these links will be live. You can look this up later, the logistical things about the product. BluVite Red is the product that we're talking about today. And that was the one that was used at Bloomfield. And just kind of saying the background is how the product works if you're not familiar. So huge disadvantage of being a plant is you're not really capable of moving from where you've rooted yourself. So plants really rely on soil microorganisms to make a living in the soils that surround them. And generally speaking, there are these very complex interactions that take place in the soil between the plant roots and these microorganisms that are root associated. And this root associated environment is generally called the rhizosphere. So this is the area that we're talking about. More specifically, soil microbes possess this machinery, the metabolic machinery, to actually access these soil nutrients, which are actually, minimally bioavailable to plants, in particular, like macronutrients like nitrogen and phosphorus. And the actual cycle that makes this happen is something called the soil microbial loop. And this is the reinforcing cycle that results in the emission of these fine lateral roots called secondary roots, which are responsible for the majority of this nutrient and water uptake. Moving on, so basically these secondary roots are very important for the longevity of the vine, especially through extreme weather events like drought or water stress, for example, because the vine can better utilize its resource pool, its water and nutrients, really, and be more resilient through these events throughout the season. And again, microorganisms are a critical piece of this loop. Taking these nutrients that are plant unavailable and making them more available to the plant. And the BluVite product line is directly stimulating this root microbial interaction in the rhizosphere. So now I'm going to start showing some data that we did in nursery trials. We've done pretty extensive studies in grapevine nurseries, both in California and Italy, to actually look at the effects of the product on overall root biomass and the secondary root production that we're talking about. The images on the next 3 slides are part of a much larger data set that was collected by my colleague Martina Ambrosio. She works for BluAgri, as we talked about in the beginning of this presentation. This slide is just a side view of the vines in the pots as part of one of these trials. And these are the same vines with a different view, which kind of gives you an indication of really the differences in vegetative growth of these young vines. But really more importantly, we want to look at the roots themselves. So I guess the take-home point from this image or these slides is there's an overall increase in root biomass and number of secondary roots, which influences the vegetative growth, the above ground growth. So I went through that pretty quickly, but I just wanted to jump into the actual case study itself. Bloomfield Vineyard, block number 10. So let's just move into the trial data. This slide's a little busy, but it lists all of the data that was collected as part of this trial so far. And I won't be able to go over all of it today. So the items in bold, I've pulled data from these different sample points to include in this presentation. But we basically have everything from early season measurements all the way through to pruning weights, which Scott's PCA and I, Chewy, actually collected just a few weeks ago in February. So the first data point here that I'm going to show today is this early season growth. So this is collected during the period where early shoot development and rapid shoot elongation occur. So you can kind of get an indication of how the canopy is developing early on in the season. So before I actually jump into the data itself, I think it's important to talk about when you apply the product. So you can see that it's applied to early season applications at bud break and pre-bloom. So if you're in the northern hemisphere, that's March, April, May, and June for that second application. You can see when the product was applied at Bloomfield, mid-March and then late May. But we target the application at this time, because this is really the most effective time to stimulate this microbial root interaction when uptake of the soil nutrients and really the accumulation of these nutrients are very active, particularly active. And this is really so we can influence, vine development for the season. So now moving on to some canopy observations and measurements. So the arrow in this image indicates an infertile bud or a non-sprouting shoot at a mid-cane position. And then, in a cane prune system, there's generally variability of shoot growth, fairly common, especially when you move outward from those mid-cane positions. And these red bars here show you the variability in that growth. The bar is the length of the shoots that are next to these mid-cane positions. And this is a side-by-side. It's difficult to tell just from a couple images, but I'll show the data in the next slide. But there is an increase in the uniformity of growth of the shoots across the cane with less variation between growth at, I guess, the mid-cane positions that we're talking about, but also the distal end of the cane and the very head of the vine where the canes are trained out from. And then looking at some of the shoot length data. So here's the actual data set. I'll show a lot of data that is sort of shown in this way, that's formulated in this way. You'll have all the data points, and then the BluVite is on the left-hand side and the controls on the right-hand side. From the data, you can actually tell that there's far more variability of shoot length measurements in the control themselves, with slightly more longer, but actually far more shorter shoots. So this really means that there's a general decrease in the shoot length variability in the treated area when compared to the control. And you can actually see this in the standard deviations between shoots within a vine and actually between shoots across vines. I've shown this data in this way before in previous presentations. I think it's a more interesting way to look at the data, really to assign a shoot quality parameter and then discuss the overall percentages of each. So a shoot grading of 0 essentially was any shoot measurement under 5 centimeters, which isn't exactly a non-sprouting shoot position, but they're not likely viable shoots, like they won't produce fruit. And then you move up from there in quality up to 4, which is what we consider regular growth. So you can actually see, just looking at the different percentages, that there's a lower number of, and actually overall percentage of these non-sprouted buds, or these weak shoot positions in the BluVite red treated area when compared to the control. There's also, from the same data, you can see there's a higher percentage of these well-developed shoots, basically a grading of 3 and above in the BluVite red treated compared to the control. So really this increased root biomass and the secondary root production that we discussed in the previous slides allows for this higher root shoot growth functional equilibrium later in the season. We also ultimately see improved ability of the vine to utilize soil nutrients and its water resource, and this manifests with a more uniform and well-developed canopy. Early season and we'll see later season measurements as well, which I'm about to show right now. So sort of fast forwarding maybe a little over a month from that data point we just saw now, this is when the vine reaches its full canopy size. Vegetative growth begins to slow. The vine transitions into more reproductive growth, and because of this, we see peak nitrogen demand occur at this time as well. So just quickly about vine balance. Again, 2 comparative images here. The extent of the canopy and the longest shoots, there's not really a difference, but it's really just this balance, this uniformity across the canopy that we see in the treated. We have this higher functional equilibrium that I keep talking about between the root growth and the shoot growth. Really which also includes mechanisms that facilitate the distribution of photosynthetic compounds, the different sinks, ultimately which are the roots and the shoots. But we're going to move into the actual fruit analysis itself to sort of shed light on that aspect. Overall vine balance in the treated area really has implications for the vine's capacity to fix carbohydrates, which are created during photosynthesis and accumulate these nutrients for growth. So if you have a short ripening window like you have at Bloomfield, being able to maximize this aspect is critical to the future ripening of that fruit with these fixed photosynthetic compounds. And he has huge implications for the quality of the fruit and the yields that you expect. So a little bit different analyses, but this is something called leaf area index, and this is very generally defined as a ratio of I guess foliage area or leaf area to ground area, and it's significantly correlated with overall radiation interception, photosynthesis, the carbon balance within the vine, very generally speaking. But really, it's an indicator for plant growth. It really has a huge influence on overall fruit quality, which again I'll cover in a few slides. But similar to what you've seen prior, there's this upward shift in overall average canopy size with 18% increase in leaf area in the treated section. This is consistent with our early season measurements, indicating that we have a higher functional equilibrium between the canopy and the roots. And this ultimately leads to more uniform growth and actually more efficient vine transpiration and photosynthesis, not only within a vine, but also between vines. And then this also has implications for water stress levels later in the season, which I'll briefly talk about. So now moving on to leaf nitrogen levels. So we use chlorophyll meters basically to monitor leaf nitrogen status. And these are widely used to guide nitrogen management and other cropping systems. But there are quite a few studies out there that show that SPAD values are significantly correlated to leaf nitrogen, also to leaf phosphorus concentrations specifically for grapevines. Generally, in viticulture, we measure at bloom and veraison. We usually do petioles. This is because approximately around 40% of all nitrogen use occurs between those two sample points, essentially from fruit set to berry softening. Similar to what we see in the canopy measurements that I showed previously, is this more uniform average leaf chlorophyll content in the treated area of the trial block at fruit set, which is when this measurement was taken. So this can be directly correlated to these higher leaf nitrogen contents at a stage where nitrogen use really is at its highest within the grapevine, basically fruit set through lag phase. So now moving on to the actual fruit quality analyses. Basically looking at certain fruit quality parameters, including potassium pH alongside extractable anthocyanins and yields. This is all of the data that we collected this year. We generally collect all this data in all of our trials for multiple sample points across the season. Again, I can't show all of this data, but I've chosen some more interesting data points to sort of talk about today that I think that people will find interesting. So I'll have a couple slides on some of these aspects that I'm talking about. So late season water stress symptoms. So there was an indication in the canopy observations from this year's trials that there were symptoms of late season water stress. And for this reason, actually, we're probably going to want to include some form of plant water status monitoring next year, or this year rather, 2021, like a midday leaf water potential or stem water potential. But that's kind of conversations me and Scott will be having. From our canopy observations, we did see a higher prevalence of basal leaf chlorosis and actually necrosis in the control area relative to the treated, which is typical signs of water stress. Without the leaf water potential data, we can only make really assumptions as to what's going on here. But I'll show some of the juice analyses that kind of back this up. But from our other trials, we had seen less water stress in the treated vines throughout the season, and that's backed up with this leaf water potential data. Yeah, and I guess as far as I know, and Scott can correct me actually if I'm wrong, but the irrigation regimes were kept exactly the same between these two treatments. So I believe the vines were on the same irrigation schedule throughout the season. So really, the point I'm trying to make here is this increased root biomass that we talked about at the beginning of the presentation allows for the vine to explore a larger soil volume, or better utilize its existing water resource, essentially utilizing it more efficiently, further delaying these water stress symptoms. And that's why these vines are exhibiting less late season water stress in the actual lower canopy. So the first bit of interesting analyses here that sort of backs this concept of late season water stress up is potassium. Late season water stress has huge implications for fruit potassium levels. These potassium channels actually get upregulated with this late season water stress pressure, or this drought pressure late season, and really this component plays a huge aspect, or a huge role rather, in the loading of potassium into berry tissues. So really, grapevines will accumulate potassium in their clusters to decrease the sensitivity to overall water stress, mostly because potassium can protect the clusters from any oxidative stresses, and it actually maintains the turgidity of the berries themselves, the membranes. So basically, because of this, when you see an increase in water stress, you actually can potentially see higher cluster potassium levels. And based from this logic, we do see a significant decrease in potassium levels in the treated versus the control, which does imply a less water stress related potassium accumulation. Why this data is important really is because it has implications for the resulting pH of the fruit, which is what I'll talk about next. So during the ripening process, just moving along here, during the ripening process, fruit pH will generally increase as you approach harvest ripeness. That's just the general pattern that grapevines follow when they're ripening fruit. But there are a handful of reasons why you would lose acidity during fruit maturation. And this includes like lower rates of acid synthesis, or loss of acid due to various mechanisms. And I'm not going to get into the logistics about that. But more interestingly, pH can increase due to an influx of potassium, which is what we saw on the previous slide, especially in this period of late season ripening. Again, like I said, in the previous slide, we saw roughly a 40% decrease in potassium concentrations in the treated block just before harvest, which can largely explain these pH differences in our actual trials. And then just quickly elaborating on this acid synthesis and loss of acid during the ripening process, we also measure total organic acid profile in all of our trials, this one as well. And in this particular case study, we can see that acid synthesis in both treatments peaked somewhere around late August, with a higher peak acid concentration in the treated area of the vineyard. But then there was also less acid loss following, basically less acid loss in the weeks leading up to harvest in the treated area, ultimately with having higher concentrations in the treated area just prior to that harvest date. So really, it's a combination of a decrease in potassium concentrations and an increase in organic acid concentrations, which ultimately explain the more favorable pHs that we see in the treated area relative to the control. Just prior to harvest. So moving on from that, from this side-by-side comparison, I always do side-by-side comparisons to show some images. You may be able to see the differences in overall cluster weights between the two treatments. Generally in our trials, we see higher yields, but this is due to more berries per cluster and actually increases in uniformity of berry size, which ultimately shifts average cluster rates upwards, so higher yields. And we see the same pattern at Bloomfield Vineyard, so pretty consistent. Here's a snapshot. I just pulled 3 data points from the season, roughly a month apart. And so you can see the averages here. So about 14% increase in average cluster weights in the treated area relative to control over the course of the season. And it changes with time, but on average, 14% increase in average cluster weights. And there's always kind of this long debated sort of dichotomy in the wine industry. Higher yields potentially can mean lower quality, but this is kind of an oversimplification. Because it's more nuanced, really, we have to track not only yields or cluster weights in this instance, but look at sort of yields in relation to other grape quality parameters such as tannins, phenolics, anthocyanins, for example. If we have this higher root shoot functional equilibrium in the treated area of the vineyard, the vines can sustain higher yields, ripe fruit at similar, if not potentially higher quality than it was previously possible. So we measure these quality parameters to support this sort of conclusion. Then kind of moving on to the extractable anthocyanin data for this particular location. Anthocyanins, hugely important for the quality of wine grapes, and they're hugely influenced by late season environmental factors. And they are influenced by viticulture practices, but canopy management, again, was kept the same between the 2 treatments at this particular trial, vineyard Bloomfield trial. We see early season, there's no statistically significant differences in anthocyanin levels between the 2 treatments at the August 27th sample point. But as the season progressed up until harvest, we see that anthocyanin levels actually decreased in the control, but we see a steady increase in the levels in the treated. So basically what this data is suggesting, it does appear that the ripening potential of the BluVite treated area was higher relative to control. And this equates to a roughly 35% increase in extractable anthocyanins just prior to harvest. So I think that's all the data I'm going to show today. Yep. And so this is just a quick trial summary here, just to kind of tie this all into a bow. But the increased overall root biomass and the secondary root production allows for this higher root shoot growth functional equilibrium. And we see this in the root biomass in our nursery trials at the beginning of the presentation, and we see this in the overall canopy growth in the Bloomfield trial example. We also see overall vine balance in the treated vineyard area. And this ultimately has huge implications for the vine's capacity to fix these carbohydrates, be more efficient at creating these photosynthetic compounds and really accumulate nutrients for growth and cluster development. And again, these fixed photosynthetic compounds are super critical for this future ripening and fruit quality and yields. We do see a decrease in these late season water stress symptoms, which is supported by this concept of increased water use efficiency. And we need to validate this point with vine water status measurements. We do this in a lot of our other trials. So I'll be working closely with Scott to make this possible for next year. So we have that data to present on too. We also see a decrease in late season potassium accumulation, improvements in yield, and then continued anthocyanin development up until harvest. So ultimately, this results in these higher levels of anthocyanins prior to harvest, but also, this can all be really attributed to these developments in the canopy themselves. So with that, I'm going to open it up for questions. So Libby, take it away.
Sure thing. I hope I do this right. Okay, so the first question is Jackson family wine related to Kendall Jackson? Scott, you're probably the best one to answer that one.
Yes, they are. Yep. Jackson Family Wines is one of their brands is Kendall Jackson, and family-owned company right here in Sonoma County.
Great. What are the reasons why this site is unique? Is it solely because of the short window of sunshine and good weather per day?
Yeah, I alluded to that a little bit. It is the small window. It's also here in Sonoma County, that site, or Bloomfield, typically around anywhere from 5 to 10 degrees cooler during the day. Like, so when I'm in Petaluma or in Santa Rosa, you're usually looking at, 7 degrees warmer. So it's cool, but it also then gets just pounded by winds in the afternoon. So the wind can damage shoots. It just makes for a very difficult growing condition.
Great. How exactly did BluVite help increase your yield? I saw this happen before your presentation, JT, so it may have been covered, but feel free to
no, yeah. So we've done some genomic studies to sort of look into exactly why we see improvements in fruit set, and some of the preliminary data. And we follow this up with a longer study. But during flowering, we actually saw higher levels of gibberellin-producing microorganisms in the Rhizosphere populations. Gibberellin is hugely important for flowering, success of flowering and fruit set. So this is potentially why we see improvements in fruit set, which is partly why we see increases in yield. But also we see maintenance of berry integrity. So in a lot of our trials that experience these water stress conditions or heat wave conditions that we experienced this last season, it's more of a maintenance of berry integrity over time, which ultimately means maintenance of yields or increases in yield when we're comparing the control versus the treatment. And then thirdly, generally with multiple years of application of the product, we see a decrease in the prevalence of blind buds. And after about 2 or 3 years, some of our long-term trials, these weaker shoots actually produce fruit, and that increases your yields as well. So there's not any one reason for this particular site. It appears that it is because of the number of berries per cluster and because of uniformity of berries within those clusters.
Great. Okay, how is this product different from its competitors like Vesta from Sobek?
I'm not familiar with Sobek. Vesta, I'm not entirely sure what Vesta is, but that might be like a humic acid kind of product. I can't really speak on what those products are. But yeah, I guess I should know this stuff, but I don't. Scott, are you familiar with either of these?
No, I'm not, JT.
Okay.
I was going to mention that we had an article published by Jancis Robinson a few months ago, and they really struggled to find a competitor product to compare the BluVite to. So as JT mentioned, I don't know about these products specifically, but what we do know is that it's a pretty unique technology.
Yeah, I would say most products out there are, I guess, what they're trying to introduce like this sort of foreign microorganism into the soil, or extract like certain components of compost to sort of boost biodiversity. So maybe these products are kind of doing either of those things.
And JT, sometimes in conversations, you'll differentiate between prebiotic and probiotic. Can you speak to that?
Yeah. So yeah, like for example, like a compost tea, that would be like a probiotic. You're trying to introduce like beneficial microorganisms into the system. There's a lot of competition already in those soils. So a prebiotic would be what BluVite is, and that's essentially trying to not introduce something foreign to the system. There's a lot of redundancy built into the system that builds resilience. So if you can stimulate what's already there, boost the overall soil biodiversity, you can then improve the overall growth of whatever you're trying to grow in that system. So like a prebiotic would be like a healthy diet. If we're using a human example, probiotic would be like yogurt. You're trying to introduce something into the system.
Got it. Okay. What is the nitrogen content of BluVite Red?
It's 0.00 something percent of the overall product, and we're talking about 33 pounds per acre of that product. So it's a fraction of a fraction of a fraction of a pound. So I mean, it's almost we have to list it on there because of whatever CDFA standards or whatever ag standards, but it's very, very small amount.
And if I remember correctly, JT, it makes nutrients more plant available, nutrients that are in the soil more plant available rather than adding nutrition to the soil.
Yeah, so it's not a fertilizer in the sense that you're trying to fertilize the grapevines themselves. You're trying to stimulate the microorganisms which then benefit the overall rooting biomass. So it's a different way of thinking about it.
And also, I've heard you say to people that it can be used in conjunction with other fertilizers to make those fertilizers more efficient.
Yeah, especially compost, we've done a lot of trials with clients and measuring petiole analyses and looking and seeing that plant nutrient status actually increases much more quickly when you have the combination of compost and BluVite within that trial.
Okay. Did you compare berry weights?
Yep, yeah, we did. That big list of different analyses that we did. Berry weights is one of those things. It was just, what makes the cut for the presentation. But yeah, we did look at berry weights in combination with bricks, also sugar per berry by volume. It tells a similar story to what we saw in terms of anthocyanin development. So I decided to look at quality relative to yields and not necessarily other ripening parameters. But yes, we did. And we do berry weights in all of our other trials as well.
And I know, as JT mentioned, he collected a lot of data. So anything that you want to see, I'm sure JT would be happy to share it with you, but we did have a limit of time today. Is BluVite a temporary application to jumpstart soil health, or is it considered to be needed annually for the long term?
Yeah, that's actually a great question. And I don't know if I have like a great answer for that, but we've seen basically, in California, we've only had about 3-4 years of application of the product. In Italy, we've had much longer. We haven't seen the ability to completely get rid of the product, but you might be able to back off on your dosage, your application rate for the season. Essentially, if you're trying to grow wine grapes and make wine from those grapes, and you're using it for certain reasons, there will always be a need for the product. But definitely being able to back off on dosage is possible, and I think that my Italian colleagues could probably speak more on that than I can.
Then for Scott, how was the control block fertilized?
Yeah, so the control block received one fertilizer application. I want to say it was late spring, so it was probably we used can 17 one time, and then everything was treated with a post-harvest fertigation as well. So it saw a little bit more nitrogen than the treated section, but yeah, probably I think we put on like 7 units of nitrogen.
Next question. The chemistry here suggests improved flavor. Did your trials also include controlled taste testing? How many trials and what were the results?
We did not do. We did not vinify the different treatments in this trial. We have done that in the past with other trials. We've poured that wine at different wine events. We had a panel on climate change. And we poured some of our a second-year trial wine at that event. And we also have done private tastings with people who are interested in using the product. We didn't do that in this particular trial, but we do have that data, both here in California, but also abroad in Italy as well. So that's something we have. Yeah.
Yeah, and I would make a comment. I think it's a great question, Russell, because ultimately we're trying to make better wine, right? But every trial is set up a little differently, and it seems like each grower has maybe a different concern or issue, and so as a result, what's measured might be different. But this is an important one.
Yeah.
This trial was with Pinot Noir. Have you seen similar results in other trials for other varietals?
Yeah. So there was a slide up that I quickly went through, but yeah, we've got trials on Rhone varietals, your common Bordeaux varietals. We've got even trials on Tempranillo, tons of Italian varietals. So it's across the board. Fortunately, and maybe unfortunately, at least in California, 70% of our trials are done on Pinot Noir and Cabernet Sauvignon. That's just the nature of the beast, especially working mostly in the North Coast. So we have so much data for both of these varietals, and I can speak confidently on the results in both of these varietals because of the sheer volume of data that we've collected. We're talking, hundreds of different trial examples for these two different varietals. Yeah.
And then a linked question, is there a varietal you wouldn't try BluVite Red with, and why?
I don't think there wouldn't be ever. I mean, people use these products on table grapes even. So I would say that there probably isn't one. I don't think we don't have data on hybrids. So that would be interesting to look into for all of the East Coast folks or higher north folks. But yeah, I wouldn't think there would be a varietal you wouldn't try it on. I don't know.
Or maybe a different question, is there a soil type that you wouldn't try it on?
Yeah, I've had some concerns talking with growers. My background's in soil science. I did a lot of vineyard development work prior to coming to Enartis. And, soils that have really high mag, we're talking like serpentine high mag, like magnesium in the soils. This product does have Epsom salts in it. So you might want to consider using this product in these soil situations. But if you have that high of magnesium in your soil, then you should probably be a little bit careful with where you're planting those grapes too as well. So.
All right. My friend is a gardener, corn, squash, peppers, etc. Any data with BluVite regarding plants like these?
I don't have any. Well, I can look out my window right now at my garden, and I use the BluVite for all of my, at least my gardens. Not, obviously anecdotally, but SOP and BluAgri. Well, actually, SOP more importantly has products for corn, for some of these other staple crops. I'm not sure if they have products for row crops. I remember some of the scientists talking about products for like tomatoes and things like that. But I'm sure they have data. We're just Enartis and BluAgri are just in charge of the vineyard side of things. So sorry, I don't have a better answer for that one.
Well, and Russell, if you weren't here at the very beginning, JT did speak to the company that developed BluVite started in other crops. So there are different products for almond orchards and olives and row crops, alfalfa, hay, corn, all kinds of crops. So yes, we have experience with those things. It's not the same composition as BluVite. So that's a roundabout answer.
Yeah, I think Greg, who is probably in this attending this meeting as an attendee, he could talk to you about that for days, and he has talked to me about it for days and
Absolutely.
days. Tons of data on that kind of stuff as well.
All right, is it organic certified?
Yes, it is. It's OMRI listed. We can work with CCOF vineyards. We also have our CDFA organic input materials certification, and that's for the traditionally applied product. So the BluVite Red. So if you go to OMRI's website, you can type in BluVite, and our licenses will pop up. You can do the exact same on the CDFA's website too as well.
Great. Can you please show the ingredient list for BluVite?
There's only 3 ingredients for the BluVite product. It's elemental sulfur, magnesium sulfate, and yeast protein hydrolysates, which are essentially just a fancy way of saying amino acids. So those are the 3 components.
Great. Does soil type influence the efficiency and uptake of BluVite? I must have asked my question before I saw this. Sorry, Lisa.
No, yeah. I mean, that's a good point. I would say that if you have higher levels of organic matter in your soils, there's a larger pool of nutrients that are not bioavailable to the plants potentially. And so, this product works directly with that kind of unavailable nutrition. And so generally the higher organic matter you have, the easier, or I guess the more quickly the plant nutrient status increases in the vines themselves. We've seen certain processes take longer. Certain things that we're monitoring in the trials take longer in soils that are sandy, like very sandy. We're talking like 0.5 to 1% organic matter. And it's hard to speak in generalities because it's soils are so diverse. So that's why we have so many different trials for so many different growers, because there's so many things to track and monitor over time. But soil type is definitely something we look at, especially when soils have a particularly low level of organic matter.
Great, and then we got a nice testimonial. I work with the Bloomfield Pinot Noir fruit and can attest to quality improvements from the previous vintage to this one. Without being able to say exactly why those improvements existed, concentration is better than previous vintages, generally speaking. Thank you, Zach. That's very helpful.
Thanks, Zach.
I'll give you that $1 I promised you after the event. Just kidding. All right. Well, those are all the questions that have come into the question and answer box. Oops. So with that, I want to thank Scott. Thank you so much for participating in this trial and helping us collect data. This has been a joy to work with you. And of course, thank you to JT, who's always out there hustling in vineyards, collecting data about BluVite. Thank you so much for all of you who attended. If you have questions or concerns or comments, feedback, we are here to listen and here to help you. And at the end of this presentation, we will send out an email for your feedback and we'll continue to be available. Here's JT's contact information.
Yeah, so stuff here. Give me a call, shoot me an email if you want to talk about soils, nerd out on data, or if you're interested in using BluVite, I'm here to talk.
Wonderful. Thank you so much, everyone. Look, we finished 2 minutes early. Well done.
All righty. Thanks, everybody.
Thanks, everyone.
Thanks, Scott.
All right.
Appreciate it.
Yep.
Bye.